Good morning, everybody. I introduce myself. My name is T. Henson. I am working as assistant professor in the Department of Mathematics, St. Joseph's College of Arts and Science, Cuddalore. I am going to teach Java programming for first MSc Mathematics, Unit 4. Now, we see the fundamentals of object-oriented programming. Introduction. One characteristic that is constant in the software industry today is the change. Change is one of the most critical aspects of software development and management. New tools and new approaches are announced almost every day. The impact of these developments is often very extensive and raises a number of issues that must be addressed by the software engineers. Most important among them are maintainability, reusability, portability, security, integrity, and user friendliness of software products. To build today's complex software, it is just not enough to put together a sequence of programming statements and a set of procedures and modules. We need to use sound construction techniques and program structures that are easy to comprehend, implement, and modify in a wide variety of situations. Since the inventions of the computer, many programming approaches have been tried. These include techniques such as modular programming, top-down, bottom-up programming, and structured programming. The primary motivation in each case has been, has, has been the concern to handle the increasing complexity of programs that are reliable and maintainable. These techniques become popular in the last decades. With the advent of languages such as C, structured programming became very popular and was the paradigm of the 1980s. Structured programming is a powerful tool that enabled programmers to write moderately complex programs fairly easily. However, as the programs grew larger, even the structured approach failed to show the desired results in terms of bug-free, easy to maintain, and reusable programs. So, object-oriented programming is an approach to program organization and development that attempts to eliminate some of the pitfalls of conventional programming methods by incorporating the best of structured programming features with several new concepts. It is a new way of organizing and developing programs and has nothing to do with any particular language. However, not all languages are suitable to implement the OOP concepts easily. Languages that support OOP features include Smalltalk, Objective C, C++, Ada, and Object Pascal. C++, an extension of C language, is the most popular today. C++ is basically a procedural language with object-oriented extension. Java, a pure object-oriented language, is one of the recent languages added to this list. The latest one being C Sharp. So object-oriented, the major objective of object-oriented approach is to eliminate some of the flaws encountered in the procedural approach. OOP treats data as a critical element in the program development and it does not allow it to flow freely around the system. It ties data more closely to the functions that operate on it and protect it from unintentional modification by other functions. OOP allows us to decompose a problem into a number of entities called objects and then build data and functions known as methods in Java around these entities. The combination of data and methods make up an object. So the data object can be accessed only by the methods associated with that object. However, methods of one object can access the methods of other objects. Some of the features of object-oriented paradigm are emphasis is on data rather than procedure. Programs are divided into what are known as objects. Data structures are designed such that they characterize the object. Methods that operate on the data of an object are tied together in the data structure. Data is hidden and cannot be accessed by external functions. Objects may communicate with each other through methods. New data and methods can be easily added whenever necessary. So it follows bottom up design. So object-oriented paradigm is the most recent concept among programming paradigms, and still it means different things to different people. It is therefore important to have a working definition of object-oriented programming before we proceed further. So our definition of object-oriented programming is object-oriented programming is an approach that provides a way of modularizing programs by creating partitioned memory area for both data and functions that can be used as templates for creating copies of such modules on demand. This means that an object is considered to be a partitioned area of computer memory that stores data and a set of operations that can access the data. Since the memory partitions are independent, the objects can be in a variety of different programs without modification. The basic concepts of object-oriented programming. As mentioned earlier, object-oriented is a term which is interpreted differently by different people. It is therefore necessary to understand some of the concepts used extensively in object-oriented programming. We shall now discuss the general concepts of OOP which form the heart of Java language. Objects and classes. Objects are the basic runtime entities in an object-oriented system. They may represent a person, a place, a bank account, a table of data, or any item. They may also represent user-defined data types such as vectors and lists. Any programming problem is analyzed in terms of objects and the nature of communication between them. Program objects should be chosen such that they may closely with the real world objects. As pointed out earlier, an object takes up space in the memory and has an associated address like a record in Pascal or a structure in C. When a program is executed, the objects interact by sending messages to one another. For example, customer and account are two objects in a banking program. Then the customer object may send a message to the account object requesting for the balance. Each object contains data and code to manipulate the data. Objects can interact without having to know the details of each other's data or code. It is sufficient to know the type of message accepted and the type of response returned by the objects. Although different authors represent them differently, the figure 1.2 shows a notation that is popularly used to represent an object in object analysis and design. We just mentioned that objects contain data and code to manipulate the data. The entire set of data and code of an object can be made a user-defined data type using the concept of a class. So a class may be thought of as a data type and an object as a variable of that data type. Once a class has been defined, we can create any number of objects belonging to that class. Each object is associated with the data of type class with which they are created. A class is thus a collection of objects of similar type. For example, mango, apple, and orange are members of the class fruit. Classes are user-defined data types. They behave like the built-in types of a programming language. For example, the syntax used to create an object is no different than the syntax used to create an integer object in C. If fruit has been defined as a class, then the statement fruit mango will create an object mango belonging to the class fruit. So programming with Java is a prime the basics idea for creating the Java program. Next, data abstraction and encapsulation. The wrapping up of data and methods into a single unit called class is known as encapsulation. Data encapsulation is the most striking feature of a class. The data is not accessible to the outside world, and only those methods which are wrapped in the class can access it. These methods provide the interface between the object's data and the program. This insulation of the data from direct access by the program is called a data hiding. Encapsulation makes it possible for objects to be treated like a black box, each performing a specific task without any concern for internal implementation. So, abstraction refers to the act of representing essential features without including the background details or explanations. Classes use the concept of abstraction and are defined as a list of abstract attributes such as size, weight, and cost, and methods that operate on these attributes. They encapsulate all the essential features of the objects that are to be created. Encapsulation is one of the three WOOP principles, the other two being inheritance and polymorphism. Inheritance. Inheritance is the process by which objects of one class acquire the properties of objects of another class. Inheritance supports the concept of hierarchical classifications. For example, the bird robin is a part of the class flying bird, which is again a part of the class bird. The principle behind this sort of division is that each derived from shares common characteristics with the class from which it is derived. In WUPA, the concept of inheritance is the idea of reusability, that we can add additional features to an existing class without modifying it. This is possible by deriving a new class from the existing one. The new class will have the combined features of both the classes. Thus, the real appeal and power of the inheritance mechanism is that it allows the programmer to reuse a class that is almost but not exactly what he wants, and to tailor the class in such a way that it does not introduce any understandable any undesirable side effects into the rest of classes. In Java, the derived class is known as subclass. Note that each subclass defines only those features that are unique to it. Without the use of inheritance, each class would have to explicitly include all of its features. Next topic, polymorphism. Polymorphism is another important web concept. Polymorphism means the ability to take one form. For example, an operation may exhibit a different behavior in different instances. The behavior depends upon the types of data used in the operation. For example, consider the operation of addition. For two numbers, the operation will generate a sum. If the operands are string, then the operation would produce a third string by concatenation. This is something similar to a particular word having several different meanings depending on the context. Polymorphism plays an important role in allowing objects having different internal structures to share the same external interface. This means that a general class of operations may be accessed in the same manner, even though specific actions associated with each operation may differ. Polymorphism is extensively used in implementing inheritance. Thank you. End.